Alright, so in the previous video we talked about how we can describe data from center and variability, and now in this video we're going to talk about the shape of the data. And I have too many things to talk about, and the major point which I wanted to talk about is actually the skewness of the data. Skewness of the data. And what this skewness is, right, we're going to understand that in couple of minutes. Probably we just wanted to understand first thing first. So when we deal with numerical data, so I'll just move next, right? Whenever we're dealing with numerical data, which means that we have sheer numbers, right? We often deal with we understand this data by multiple other things, like we talk about the center, we talk about how my data is varying, and there comes the logic of shape, right? And what this shape exactly means, right? So first thing first, let's understand a couple of things here, right? Say I have some data, right? So I go to a school, right, and there I see there are too many kids, right? And I wanted to like pick up like random like kids and wanted to measure their age in numeric numbers. So I will get something like this, right? So we have a kid whose age is 5 years, another one who's 6, another one who is 7, somebody who's 11, somebody who's 10, somebody who's 9, then you got 7, then you got 7 again, you got 5, then you have 8, somebody is 6, somebody is say 10 again, somebody is 11, then you have 7, then you have 6, then you have 11 once again. Okay, now this is what I wanted to write. Now if I wanted to represent this data, right, I have too much of data, right? I wanted to understand how can I have a better representation of this data, and if you wanted to better representation of this data, you wanted to create something called as frequency table. I'm coming up to a very important logic. I want you to understand this. This is called frequency table. Now what this frequency table is, right, so here I will be writing like the age, right, and here I would be writing the frequency of the data. So maybe I just so I'll just forget about this tilted line over here. So we have age, right? So how many kids we have with age 5? So we have 1, then we have 2 kids, the number of kids are 2, then we have 6 over here, then we have 1, 2 and 3, so we have 3 kids who've got the age of 6, then we have 7, so I'm just marking it so that you can remember, 1, 2, 3 and 4 kids who are having the age of 7. Then we have 8. How many kids have got age of 8? So I'll say 1. And then we have 9. How many kids have got 9 age? So this is only 1. And then I would say 10 over here, like, so we have got 1 over here and 1 over here, and I would say 2 kids. And then how many kids have got the age of 11? So this is 1, 2 and 3. So this is more of a frequency table, right? What I've got over here is a frequency table, and what this frequency table does is actually gives you some kind of idea how many kids. Now how many kids are there of what kind of age? Now if you just think about these table, this is actually simplifying the data. So even if I have, say, kids, so generally the kids in the schools are ranging from 5 to say somewhat 19 approximately, or maybe like depends upon the country, like you have say 18, right? Maximum is 18. So you have most of the people who are lying in from this age to this age, and I can no matter like how many numbers I have over here, I can convert them into a frequency table from 5 to say 12, and then 13, and then 14, and so on and so forth, and I'll have an exact idea how my whole data is all about. Now if you understood this frequency table, right, I wanted to describe this into a better representation of the data. And what is that better representation of the data? So I'll just change the color of it. I'll probably make it little blue, right? So this is something called as, I'll just create a graph for you over here. So I've got a line and I've got line over here. So I've got 5, I've got 6, this is 5, 6, then you have 7, then you have 8, then you have 9 and 10, and you have 11, and then you have number of people, right? So 1, 2, 3, this is 3, 2, 1, 4, and we know that we have only 4, but I'll just create one more, 5 and 6 over here. So you've got these many kids, right? So what I'm going to do is I'm going to create the dots. Okay, how many dots we have? So we have what? So for 5, age of 5, we have 2 numbers. So I'll say 1 dot over here and 1 dot over here. And the second is age of 6, we have 3. So we'll say 1 dot over here, 1 dot over here, and 1 dot over here. And then 7, we have 4, 1, 2, 3, and 4. And then we have 8, only 1, 9, only 1, 10, we have 2, 1. Sorry, this, let's keep it this way, 2 number over here, and 11 we have 3. So 1, 2, and 3. This representation of the data is called dot plot, right? So when you say the dot, the values over here, this is called dot plot, right? So this representation, and if you just look at this, this information, this whole information can be represented in this way, right? So you can see a dot plot, and then dot plot can exactly tell you what this frequency table is all about. Okay, but now there could be another way of dealing with it, right? Now what I'm going to do is I'm going to pick up the eraser over here, and I'm just going to pick up the same data, right? And I wanted to create something new for you guys. Let's see how it works. So imagine we have the same data, right? Now if I wanted to represent the same data into a different information altogether, how would I do that? Now in order to do that, what we need to do is we need to create one more table, and that table will be something like this. Okay, so what we'll say is like how many people we have from 5 to 8, right? So I'll just write it over here, 5 to 8, and then we have 8 to 11, or maybe 8 to 10, or we can just simply try a different stuff. Okay, maybe, yeah, that will work, right? And then we can have 10 to 15, right? How many kids we have from 10 to 15, and imagine we have this same data right over here. So what am I going to do is I'm going to write this over here. So we have 5 to 8 age, right? And how many kids we have? So you can just simply calculate this number. So 2 plus 3, 5, plus 4 is 9, plus 1 is 10, and then we have 8 to 10. Okay, sorry, I have to take 5 to 7 over here. Sorry guys, 5 to 7, and I'll just keep 5 to 7. I'll just maybe I'll delete that, right? So I'll just delete that, and I'll just delete that as well, and I will just write 5 to 7, 8 to 10, and then 11 to 15. Okay, so 5 to 7, right? We need to calculate till here, right? Till here. So this is something which we need to calculate. So 2 plus 3 plus 4 is 9, and then we say 8 to 10. How many kids we have? 8 to 10. So we'll calculate this one, which is coming out as 4, and then we have 11 to 15. And so imagine that we do not have any number in 15 or something, right? So we'll just simply say 11 to 15 is, we have all in all in total is only three kids, right? 3 kids out there. Now what exactly I have done over here, if you notice this pattern, right? What I have done is I have actually grouped the data, right? Grouped the data, right? And this grouping of the data, or we can call it as, so if you just notice over here, we have grouped the data, and this is the number, right? This number is what? This number is frequency of a particular number occurring. Frequency of a particular number occurring, right? What is that frequency? How many times 5 to 7 years of like age kids appearing into the table. So we have got the frequency over here. So 8 to 10, how many times? Like appears 4 times. And if I wanted to represent this data, very unlikely to the way we have seen earlier, in the dot plot, what we are going to do is I'm going to create a value over here 5 to 8. Sorry, I need to be very cautious with that number because I just keep on missing that out. I will just simply say 5 to 7, right? 5 to 7, and then I would say 8 to 10, and then 11 to 15. Okay, and what am I going to do is I'm going to say, right, 1 2 3 4 5 6 7 8 9, and this is 10. I would say this is the frequency for 5 to 7, and then we have 8 to 10, which is 4 1 2 3 4, so we have 4 number over here, and then we have 11 to 15, which is 3, and you can have number 3 over here. So this value over here is a different graph altogether, and this value over here is a different graph altogether, right? So you can see over here now this kind of graph, or this graph over here which we have seen so far, is called histogram. And histogram is all about the group frequency. Now sometimes we do not have the numbers, so at times you just wanted to, and most of the time, like, what happens is, like, you have 4.1, the age of a person is 4.1, and then 4.2, and then 4.3, and 4.5, right, and 4.6, right, and then we have many people who've got the 4.5, 4.5, 4.5. What I wanted to do is I wanted to understand how many kids are between 4 to 6, right? I can just, like, combine all that frequency, or I can just simply say how many kids are lesser than 5. I can do that multiple things with that histogram. So I hope it is making sense what this histogram can do for you, right? And what we can do with how we can read this histograms and everything, right? Now the again I wanted to talk about different things, right? How would you read that histogram? So I'm going to delete everything from here, right, and I would just simply say erase everything, and I'm just going to show you a couple of things, right? Now just think, if I have a histogram, right, and I'm not writing the numbers over here, right, I'm writing this histogram is something like this. Now I have a histogram something like this. You can imagine these are like equidistant number over here. What this graph shows you, right? So basically what you can do is you can understand, right, what is lying where. So I can say most of the people, like, these many people are lesser than a certain number, and these are the people who are greater than a certain number, right? So we can just simply have some numbers on x-axis and y-axis, and I can start reading it. But why we want to create this graph, and can we have a better way of visualization of this same data? What I wanted to do is I want to create a simple graph, a simple histogram for you, something like this, right? And if you remember in your college time, or school time rather, your teacher might have asked you to create these kind of graphs, and what they have asked you majority of the time is that what you need to do is you need to pick up the center point of these values over here. These are the center values of this graph, and what you want to do is you wanted to connect them via a smooth line, something like this, something like this, right? And if you just understand that what I'm trying to do, I'm just trying to create a smooth line towards a graph, and it goes something like this, right? And if I just pick up the line only, right, I will have a graph very much like this, okay? This is I'm just removing these staircases over here, and this is the representation, one of the representation of the data which we have seen earlier, right? So for this graph, the representation would be something like this, right? Representation would be something like that. You can just imagine a smooth line passing from the centers. Now if you have this kind of data, right, now this kind of data is actually having the median value somewhere here, right? So if you just drop a median value, and we know what median value is, right? Median value means the number of elements we have, number of elements, right? The number of elements on this side before median is equals to the number of elements we have on the right side of the median. So we have the equal number of, it's called equal frequency bin, so we have equal number of elements. And we can also say that we have left hand side is equals to right hand side of the graph. So which means that if I draw a line, which is something like this, we will have mirror images, right? And this kind of graph is called symmetric graph. This kind of graph is called symmetric graph. Okay, and most of the time the values are lying at the same point, right? Like it's always center is nearby to median values. Okay, so this is how we call it as you know, a normal distribution, and it looks like a bell, right? So you can call it as, sometimes you can call it as, so there's much more things to normal distribution, but just want to call it as bell shaped, right? And you might have heard about this bell curved. It's also called as bell curve, right? So you can call this as bell curve, and this bell curve is having LHS is equals to right hand side. Now when it comes to bell curve, there can be multiple bell curves, right? And how these multiple bell curves work, basically you can have the bell curves which are like this, right? Or you can have a bell curve which is going like this, right, which is also asymmetric. Or you can have a curve which can go something like this, right? So consider that you know that you have the same peak point over here. So the range over here, range of this graph is from here to here. For this graph is from here to here. However, for these, I'll just change the color just to make you understand. So if you just notice this graph and this graph over here, they have got same range, right? And this graph, this one and this one have same peak, right? So what we need to do is we need to understand how we are going to define our different you know, graphs, and based on that we can decide, you know, how my graph looks like. So you have to have the complete understanding. So this is called leptocortic and mesocortic, right? We have where the peak is getting you know, there are different ways to define the peaks as well, which is called leptocortic and mesocortic. And we wanted to first understand like how we have different kind of symmetric graph and how we can have a different kind of asymmetric graph. So I'm just going to delete all of this, and I want to create another diagram. So over here we have something called as symmetric graph, and symmetric graph is something like this. This is what we have understood in the previous slide. And we can have asymmetric graph as well, wherein we can have data something like this, or we can have data which is something like this, right? Or we can have data which is something like this, right? Or we can have data which is something like this, or we can have data which is something like, something goes like this, and we have something like this, right? We can have multiple things over here, right? So we can, so you can see that you have like several you know, several blocks over here, and we also have a block over here as well, right? This is also one of the block, and we have multiple blocks over here. Now what kind of graph we are creating over here? So this is definitely a symmetric graph, symmetric graph. And we have non-symmetric graph. So these are all non-symmetric, right? So I'll just write NS over here. This is non-symmetric graph, and this is also non-symmetric graph. This is again a non-symmetric graph. This is again a non-symmetric graph. This is also a non-symmetric graph. But what is the difference between what do you call, apart from this, like what do you call this graph over here? So just look at this, right? We have the if you just notice here, the median of this value is somewhere lying over here. For this, the median value is lying somewhere over here, right? Median value is lying somewhere over here, and this is right skewed graph. This graph is little bit skewed on the right hand side of it, so we'll say right skewed graph. This graph is left skewed graph, left skewed graph. Okay, and this graph, now this graph is neither left skewed or right skewed. What do you want to call it? So there is a different term, right? So we have one term called unimodel, and we have a term called bimodel. And what this unimodel and bimodel are doing, unimodel means that you have only one peak of the data. This is very much something like this. So we have right skewed, so you need to write here. I'll just change the color of the pen so that you can see that unimodel right skewed data, right? Unimodel, this is also unimodel right skewed data. Okay, and this is bimodel data. This is also bimodel data, right, where we have two peaks of the data, right? Now there is also something called as gap. This is a gap where the value of a particular thing is 0. For example, if we are picking up the kids, right, so the kids are ranging from 5 to 10 years of age, and then we have 12 to 18 years of age, but nobody, it could be by chance, right? I'm just giving you one example. There is nobody who is a range of 11. There's no kid who is a range who has the age of 11 years, right? This is what it shows. Over I can see over here the kids who are ranging from 7 to 9 are pretty high. However, when it comes to 10 years of age, pretty low. And then when it comes to 11 to 15, most of the people are like ranging from this. And then there is very few people who are having 16 or 17 years of age, right? Now you must be wondering, Sudhanshu, now I'm a little bit confused. Like, how would you define this? So you would define this as bimodel. This is bimodel for sure, and you also have a gap over here. This is also a gap, right? I will write it as gap, and there is something called as outlier for this data. This is also called as outlier of the data. This is outlier. We'll talk about like the formal definition of outlier, what this outlier is in terms of statistical term, but I hope it is making sense, right? What this all values are. So we have gap, we have bimodel, we have outliers, and you define your total data on the basis of that only, right? There is one bigger possibility which I wanted to talk about is what will happen if I have graph like this, right? What will happen if I have graph like this? Now there is no peak, there is no bimodel, everything is consistent, everything is consistent over here, right? So we call this kind of graph, we call it as zero peak, right? Zero peak data. And what this zero peak data means, that we have something called as uniform data, right? Uniform data across. So we will call it as uniform data, right? And we call it as zero gaps. So we have data, we can have like multiple things, and we wanted to, if you wanted to describe, right, in your data, you can describe it with center, spread, shape, symmetry, peak, skewness, uniformity, and then if you have any gap or outliers or not, right? So you can just pick up multiple things in the data and you can describe it. I hope it is start making sense. In case you are not able to understand it, please try and go back and study this video. This will help you understand multiple things, and we will have some exercises based on that as well. So we will use them, right? I hope it makes sense to everyone, and I'm going to see you in the next video where we'll talk more on the different kind of data.